This lecture is about the text categorization. In this lecture, we're going to talk about the text categorization. This is a very important technique for text data mining and analytics. It is relevant to discovery of various different kinds of knowledge as shown here. First, it's related to topic mining and analysis. And that's because it has to do with analyzing text data based on some predefined topics. Secondly, it's also related to opinion mining and sentiment analysis, which has to do with discovering knowledge about the observer, the human sensor. Because we can categorize the authors, for example, based on the content of the articles that they have written. We can, in general, categorize the observer based on the content that they produce. Finally, it's also related to text-based prediction, because we can often use text categorization techniques to predict some variables in the real world that are only remotely related to text data. And so this is a very important technique for text data mining. This is the overall plan for covering the topic. First, we're going to talk about what is text categorization and why we are interested in doing that in this lecture. And then we're going to talk about how to do text categorization, followed by how to evaluate the categorization results. So the problem of text categorization is defined as follows. We're given a set of predefined categories, possibly forming a hierarchy also, and often also a set of training examples or a training set of labeled text objects, which means the text objects have already been labeled with known categories. And then the task is to classify any text object into one or more of these predefined categories. So the picture on this slide shows what happens when we do text categorization. We have a lot of text objects to be processed by a categorization system, and the system will in general assign categories to these documents as shown on the right and the categorization results. And we often assume the availability of training examples, and these are the documents that are tagged with known categories. And these examples are very important for helping the system to learn patterns in different categories. And this would further help the system then learn how to recognize the categories of new text objects that it has not seen. So here are some specific examples of text categorization. And in fact, there are many examples. Here are just a few. So first, text objects can vary. So we can categorize a document or a passage or a sentence or collections of text. As in the case of clustering, the units to be analyzed can vary a lot. So this creates a lot of possibilities. Secondly, categories can also vary. And we can in general distinguish two kinds of categories. One is internal categories. These are categories that characterize the content of text object. So for example, topic categories or sentiment categories, and they generally have to do with the content of the text objects, direct characterization of the content. The other kind is external categories that can characterize the entity associated with the text object. For example, authors are entities associated with the content that they produce. And so we can use their content to determine which author has written which part, for example, and that's called author attribution. Or we can have any other meaningful categories associated with text data, as long as there is a meaningful connection between the entity and text data. For example, we might collect a lot of reviews about a restaurant or a lot of reviews about a product. And then these text data can help us infer properties of a product or a restaurant. In that case, we can treat this as a categorization problem. We can categorize restaurants or categorize products based on their corresponding reviews. So this is an example of an external category. Here are some specific examples of applications. News categorization is very common. It has been studied a lot. News agencies would like to assign predefined categories to categorize news generated every day. And literature article categorization is another important task. For example, in biomedical domain, there's this MESH annotations. MESH stands for medical subject heading, and this is the ontology of terms to characterize content of literature articles in detail. Another example of application is spam email detection or filtering. Right? So we often have a spam filter to help us distinguish spams from legitimate emails. And this is clearly a binary classification problem. Sentiment categorization of product reviews or tweets is yet another kind of applications where we can categorize content into positive or negative, or positive and negative, and or neutral. Right? So you can have sentiment categories assigned to text content. Another application is automatic email routing or sorting. So you might want to automatically sort your emails into different folders, and that's one application of text categorization, where each folder is a category. There is also another important kind of applications of routing emails to the right person to handle. So in the help desk, an email message is generally routed to a particular person to handle. Different people tend to handle different kinds of requests. And in many cases, a person would manually assign the messages to the right people. But you can imagine you can build an automatic text categorization system to help a routing request. And this is to classify the incoming request into one of the categories, where each category actually corresponds to a person to handle the request. And finally, author attribution, as I just mentioned, is yet another application, and it's another example of using text to actually infer properties of some other entities. And there are also many variants of the problem formulation. And so first we have the simplest case, which is a binary categorization, where there are only two categories, and there are many examples like that. Information retrieval or search engine applications would want to distinguish relevant documents from non-relevant documents for a particular query. Spam filter is interested in distinguishing spams from non-spams, so also two categories. Sometimes classification of opinions can be in two categories, positive and negative. A more general case would be K-category categorization, and there are also many applications like that. There could be more than two categories. So topic categorization is often such an example where you can have multiple topics. Email routing would be another example where you may have multiple folders, or if you route the email to the right person to handle it, then there are multiple people to classify. Right? So in all these cases, there are more than two categories. Another variation is to have hierarchical categorization, where categories form a hierarchy. Again, topical hierarchy is very common. Yet another variation is join the categorization. That's when you have multiple categorization tasks that are related. And then you hope to kind of do join the categorization, try to leverage the dependency of these tasks to improve accuracy for each individual task. Now, among all these, binary categorization is most fundamental. And partly also it's because it's simple, and partly it's because it can actually be used to perform all the other categorization tasks. For example, K-category categorization task can be actually performed by using binary categorization. And basically, we can look at each category separately, and then the binary categorization problem is whether an object is in this category or not, meaning in other categories. And the hierarchical categorization can also be done by progressively doing flat categorization at each level. So we can first categorize all the objects into, let's say, a small number of high-level categories, and then inside each category, we can further categorize into subcategories, etc. So why is text categorization important? Well, I already showed you several applications, but in general, there are several reasons. One is text categorization helps us enrich text representation, and that's to achieve more understanding of text data. That's always useful for text analysis. So now with categorization, text can be represented in multiple levels, meaning keyword, bag of words representation, that's often used for a lot of text processing tasks. But we can now also add categories, and they provide 2 levels of representation. Semantic categories assigned can also be directly or indirectly useful for application. So for example, sentiment categories could be already very useful, or author attribution might be directly useful. And another example is when semantic categories can facilitate aggregation of text content. And this is another case of applications of text categorization. For example, if we want to know the overall opinions about a product, we could first categorize the opinions in each individual review as positive or negative. And then that would allow us to easily aggregate all the sentiments. And it would tell us about 70% of the reviews are positive and 30% are negative, etc. So without doing categorization, it would be much harder to aggregate such opinions. So it provides a concise way of coding text in some sense based on our vocabulary. And sometimes you may see in some applications text categorization is called a text coding, encoding, with some controlled vocabulary. The second kind of reasons is to use text categorization to infer properties of entities. And text categorization allows us to infer the properties of such entities that are associated with text data. So this means we can use text categorization to discover knowledge about the world. In general, as long as we can associate the entity with text data, we can always use the text data to help categorize the corresponding entities. So it's useful to think about the information network that will connect the other entities with text data. The obvious entities that can be directly connected are authors, but you can also imagine the author's affiliations or the author's ages and other things can be actually connected to text data indirectly. Once we can make the connection, then we can make prediction about those values. So this is a general way to allow us to use text categorization to discover knowledge about the world. Very useful, especially in big text data analytics, where we are often interested in using text data as extra sensor data collected from humans to infer certain decision factors, often together with non-textual data. Specific to text, for example, we can also think of examples of inferring properties of entities. For example, discovery of non-native speakers of a language. And this can be done by categorizing the content of speakers. Another example is to predict the party affiliation of a politician based on the political speech. And this is again an example of using text data to infer some knowledge about the real world. In nature, the problems are all the same, and that's as we defined, and it's a text categorization problem.